All right, thank you, Laura. Welcome, everyone. So as you can hear, I'm no English native speaker, so I hope it will be as clear as possible and let me know if something is not clear enough, okay? So I will speak a little about open access and open research data in Horizon 2020. So first of all, what is open access? So open access is about sharing and reusing information. It's an incentive policy fostering researchers to share widely and openly scientific information, following three key principles. First, online sharing, so it needs to be shared on the web. Then it needs to be free access. And then the information needs to be reusable. And this is very important, we come back to that later. And the content needs to be persistent, which means it's supposed to have an archiving policy and a clear archiving policy. So open access is free, as immediate as possible. About articles, it should be online, available, and reusable. And it can be applied to publication, but also to other type of materials like data and datasets, and it's also the case in H2020. Then open access is not just about publication and data, it's part of a global ecosystem. So open access of publication, documents, materials, different type of publications, then about open data. But it can also be about open education, like MOOCs, for example. It can be about open government, giving more transparency about public policies, public documents. It can be about license, open licensing of content, which make them reusable, as we will see later. About open scholarship, globally about open science, and about open source software, which can be very useful. So why do we need to give credit to open access and to make things open access? Then first it can be more exposure for your work. The more people can see your work, reuse it on the internet, the more credit they can give to your work and reuse it. Then practitioners can apply your findings. Science is a cumulative process, so you don't have to redo everything that has already been done by previous researchers. So this is important that you can reuse that to make innovation. Then studies have proved that open access publication is sometimes twice or third time more cited than regular publication. It depends sometimes on the disciplines, but globally open access publication have higher citation rates. Then it can also influence policies. It is science for the society, and it can help to change way of thinking, way of doing science, way of doing politics, way of doing whatever you can imagine. Then the public can access your finding because it's in internet, so you can reach public outside the small academic world, because if it's openly accessible, then other people outside of your coworker or collaborator can reuse it and create some innovations with your research in a multidisciplinary way. Then open access is also about complying to rules fixed by grants, and that's the case in H2020, as you know. It can also give more value, or taxpayer can get value for the money as they make an investment by financing the research, and they want to have a return on investment on that. So open access is helping to get a better return on investment. We will see later why. And then something that's also important is that researchers from developing countries can also see your work and benefit from it, because studies showed that there is a very unbalanced contribution between northern and southern country regarding contribution to science publication and to access to science. So open access is clearly a way to get this contribution balanced. So there is other argument, but it is mainly why open access is interesting for research. Then, what is exactly open access? There is different way of doing open access. There is, and it's supposed to come back a little bit on the publication process globally. So first, there is the classic way of publishing things. So as a researcher, you write a preprint, then you submit it to a publisher. You get the review of an expert committee, so peer reviewer, which improves most of the time the paper, the preprint, and keeps the postprint. And then this postprint is transformed into PDF with the publisher framework, and it becomes the PDF editor. And then it is published in a journal that is usually not open access, and the only way for institutions or other researchers to access the content of your article is to pay and to subscribe to the journal. So as a public institution, for example, as a university library, you need to pay twice, because first you need as an institution to pay to finance the research, and then you need to pay again to access it. It's almost as if the baker had to bake his own bread at the end. Then there is the first way of doing open access. It's the green open access path, which is also called the safe archiving. So it's about archive, HAL. The principle is that you take a preprint and you put it by yourself in an open repository. So it's free. It just takes time because you need to do it by yourself. And then everyone can access it on the internet through Google Scholar, or whatever search engine that search your repository. The problem with this path is that researchers often say that how can you be sure that the paper is a quality paper? That's the reason why we encourage researchers to do the second and to use open access repository, but to put their postprints in it. Most of the time, publishers allow researchers to put the postprint into open access repository after a certain time. So when the embargo fixed by the publisher is over, then you can take your postprint and put it into the green open access repository, which allow you to benefit from the reputation of the review and from the comments and improvements of the expert committee. And then at the end, it is immediately or after 6 months or 12 months, accessible openly on internet through the repository, for example HAL, which is the French National Open Access Repository that everyone can use even if you know French, but this is what's recommended for French researcher. Then the last path of doing open access is the one that is usually the more practiced by researchers, is the gold open access. It's also, we also call it the author-payer path. And it's almost the same as the classical way of doing publishing, because you do your preprint, you submit it to the publisher, then you get your postprint, which is the improvement of an expert committee, because it's mostly the same journal that offers the classic way and the gold way of doing open access. The difference between the blue line and the gold one is that when you want to publish it, you can say that you want to do it open access, and then the publisher will say, okay, no problem, we can publish it open access freely, not freely, but you have to pay APCs. So APCs are article processing charges, which suppose that you, as an author, have to give money to the publisher to make your article in open access. And at the end, an institution, library, or other researchers can access it. But there is two different gold open access paths. The first one is the hybrid, which means that only your article will be in open access in a journal that is not open access globally. This is the worst way of doing open access because you need to pay once as an institution to finance the research, then your laboratory or your institution need to pay again to make your article open access, and then you need to subscribe to the journal. Even if one article is open access, you need to access the other article, so you still have to get subscription to your journal. So actually you pay 3 times to access something that you finance in the first way, in the first time. And then the last path is the full gold open access, which is better than the first one, but still a bad solution in our opinion, but sometimes you don't have the choice, is that your article will be in open access in a journal that is globally in open access. So this is more interesting, but you still have to pay 3 times to access the content. For that reason, we definitely encourage researchers to combine as much as possible the first 2 paths, even if you have to wait 6 months to 12 months. From the purely economic point of view, it is more interesting than doing gold open access. And in any time, in any way, if you do, whether you do the classic path plus gold or the gold open access, and it's the case in Horizon 2020, you have to deposit your publication in an open access repository. Why? Because even if you do open access as a gold path, this is the editor who would put the content in open access. If the editor of the journal disappears, the publisher is bought by another publisher, the content is no more available on internet. So to make sure that your publication will be persistent in the time and preserved for a long time, you need to put it in an open repository, because open repository is archiving, self-archiving, and it means that we guarantee that if you put your documents in HAL or archive, you will have long-term preservation. So this is important to do anyway, green open access, and this is one of the requirements of H2020. So what is exactly open access and open data in H2020? First, this is a core principle of the European Commission, because open science is part of progress and prosperity for the European Commission. That was the original leitmotif. So what it means for you, it's some stuff are required by Article 29.2 of the grant agreement. So you have to disseminate your research. It means you have to disseminate first publication in a gold or green way, and to deposit also research data and to make them as much as possible freely accessible. But we know that sometimes you need to protect them, so we'll come back later to that. So I think it's pretty clear. So you have dissemination issues, but you also have data management issues. So what do you need to do for data? Because it's more complicated than for open access to publication. In any way, you don't have to publish, but if you publish, you need to put your article in open access. For data, it is a little bit more complicated. First, the open access to research data was a pilot, which aims to improve and maximize access to publication and reuse of research data. So what you have to do in the ORD pilot is to provide a data management plan within the first months of the project. And it is mandatory even if you don't give access to your data. You have to manage them. Then you need to deposit your data and your metadata associated with the data into a repository. And you need to make sure they will be preserved. First, when they first launched the Horizon 2020 program, the ORD pilots applied only to those themes. But since January 2017, so since January of this year, the pilot was enlarged to all thematic areas of H2020. So you don't have the choice anyway. You need to manage data and to give as much as possible access to them. So what kind of data are concerned? Sometimes there is mistake made with big data, open data, research data. The pilot is about open research data. So you need to manage your research data, but just a part can be openly put on the internet, because sometimes for legal issue or for patent issue you can't provide everything freely and accessible online. Sometimes it can be big data that is also need to be openly accessible, but it's not mandatory. So you need to find the right type of data that you want to open. But in any time you need to, in any way, you need to manage all your research data. What about evaluation? About in H2020, management of data and open access to data is not part of the evaluation. It's still a pilot, so you can step out of the pilot if you want, but if you didn't step out, you need to follow the principle. And I think that MiRoR didn't step out of the pilot, so you need to comply to the rules as much as possible. But there is different reason for stepping out of the project, or even if you don't step out, to take few data sets out of the project, because it will jeopardize the achievement of the project. It is incompatible with prediction of privacy issue, or for other legitimate reasons, as you can see. So you have the choice, you just need to justify the reason why you want to step out. Something else that I would like to make clear is the difference between data management and data sharing. As I already explained, you need to manage data, whether you share them or not. Reason for not sharing data can be various, but it is important that to be able to share data, you need to manage them first. It is very difficult to share data and to make them reusable and understandable for others if you didn't manage them, provide good quality metadata, and extra. So why do we need to manage data and share data? For almost the same reason as publication, to reuse them as raw material for new research, to generate new opportunities, innovation, interdisciplinary innovation process, to have a better dissemination of science, to try to have access to not replicable results. For example, in astronomy, it's very, very expensive to have results. You need to have big engine, large amount of data. So science is not always reproducible. So by sharing it, you can give more access to them and can be used by a wider group of people. It's also saving money by not redoing what has already been done somewhere and using it to guarantee a better control and reliable results. You know that there is some still fraud in articles, so if you have access to the data, you can check if the results are really what they pretend to be. And it can give you more visibility about around the world on your research activities as a university or as a project. So what is a data management plan? Maybe some of you have already heard about that. This is actually no big deal. It's just putting in the same document, in one unique document, some other stuff that you've been putting in different documents before. You have to explain in that document what is your project briefly, what kind of data you're going to be producing, what you will be doing with it. Actually, if you are if you're going to publish article with this data, how do you manage them? How do you preserve them? What are the ethical issues about those data? If you have the money, if you have the people to manage them. So those are different, how can I say that, questions you need to answer about your collection. What data will you be collecting? How do you collect them? What documentation and what metadata will you be using to describe the data? What are the ethical issues? How do you handle copyright and intellectual property rights about your data? How do you store them? What kind of backup and security warranty do you provide to be sure that your data will not be erased by mistake or whatever? What kind of preservation means do you use? How do you share them? Will you share it, and if not, why? And who will be responsible for that? As Laura told me, I think everyone will be responsible for his own data, so it is important that everyone provides a little paragraph in this global data management plan to explain what you will be doing with your data and how do you handle the whole data life cycle of your production. So globally you produce data, then you need to provide information about in the DMP, then you will store your data on your own computer, on a global server, in Dropboxes or whatever. What kind of treatment analysis you will do on those data? How do you describe them? What kind of metadata are you using? Is it a metadata standard for your discipline? Is it something that you created by your own? How will you be disseminating it, protecting it, and who or how do you archive your data? So this is an example of data management plan that was provided by another H2020 project. It's about informatics. It's just an example as how a data management plan can look. So it's mainly written, and then you have the plan, so project information, data responsibility, so the different data sets that were produced by different partners, and then global information about publication associated to the data, the related publication, data storage, access and security, and some definitions that help to understand the data management plans. And as you can see here, there is different time to provide data management plan. It's a revised document. You need to provide a first DMP at the beginning of the project. Then at midterm, you need to provide another one. I mean, actually it's the same one, but to give more information about what you have been doing during the first time of the first part of the project. And then you need to make another version, the third version of the DMP for the final review of the project. So this is globally the calendar of the data management plan, and it's important to keep it as updated as possible. It is not taking into a deep account for evaluation, but it's still important to do it seriously if you say you will be doing so. So how do you comply to all those requirements? First, you have tools to help you do your data management plan. So this is a spreadsheet that you can access on this address URL that we provided as Paris Descartes and Paris Diderot University. It is just a spreadsheet with a guideline, so it's pretty easy to do. There is explanation. Some of the explanations and requirements are translated, so you can use it and ask us any question you like about it. But there is also online tools which can be pretty useful for you if you are all disseminated around the world. So for photo, the pictures I showed you in the previous slide were taken from the DMP Online, which is a tool developed by the Digital Curation Center in Great Britain. And it's one of the tools recommended by the European Union to produce data management plan. The guidelines are not very detailed, but you can. It's still pretty easy to use. So you can create. I'll show you an example. So this is, you need to log in as an individual user, and then you can create a template. So one of you can do it, and then you have access to the same framework, and you can share this document with other person and give them right to co-edit, to co-own, or as simple reader of the document. So this is one tool that is pretty easy to use, and that can be very useful for you. There is other tools that can be used. For example, the DMP tool, which was provided by the American University, I think it's the University of California. It is more American tool, but you can use it as well and log in as an individual user and then share your data management plan with other people and other partners. And the DMP OPDOR is the one provided by the CNRS in France, with the research agency, which is almost the same thing as the DMP Online, only a little bit translated and adapted to the French way of doing research. So you can use those things. Then, how do you deposit, to choose a repository for your publication? I told you you can do gold open access, but then you still have to deposit your publication into a repository. So what to deposit first? The H2020 grant agreement say that it should be a machine-readable electronic copy of the published version. So the postprint or the PDF of the publisher is willing to give you the right to do that, or the final peer-reviewed manuscript. So it is the postprint. You also have to ensure open access to the metadata. So this is important. Then when to deposit? The European Commission has fixed 2 mandatory embargo, 6 months after publication if you are publishing in life science, and 12 months if it's in human sciences or digital humanities. So I think for you it would be 12 months. It is important because it means that whether you need to find a journal that allows you to do so, or you need to do the gold open access path, because it's the only one that allows you to do open access previously to those 12 months, or not after the 12 months, but it has a cost. And I remind you that costs are eligible, open access costs are eligible in H2020 project. Then, where exactly should I deposit? You can find, so I told you about archive, but it's more about a repository for physics and chemistry and hard science content. You can use AL, which is the French repository, but it's a global multidisciplinary repository, or you can find other repository using OpenDoor. So OpenDoor is the directory of open access repository, so you can browse by subject area, country, language, type of software to find the repository that you would like to use. Or you can also use the centralized repository, for example Xanadu, that can be used for data and for publication, and this is the one you choose, so I will explain to you later about it. Just an example for the French researchers who would like to submit to AL. It's always worked the same. You have to select a file or to put a URL where the file is already stored, and then provide few metadata. For example, for photography, you need to give the source, to give the credit, the date where the photo was taken, the city where it was taken, latitude, longitude, etc. But first, in every repository and every tool I will show you, you need to log in and create a free, usually free account, but you still need to create an account to use the service. So for example, if I go to AL, I logged with my own account, and I can see all the paper I've been depositing. So for example, I've deposited this document for someone else, because you can publish and deposit a document for someone else and then share the property with them. And if I show you the metadata used for a paper, an article, sorry, this one. You need to choose the type of publication you will be submitting, and you need to choose license to guarantee that the publisher was okay to allow you to deposit into HAL. You can give the persistent identifier like a DOI or ARC handle, what type of persistent identifier you want to use. Then you need to give the title, a quick resume or a quick abstract, keywords to describe the content, precise language, give the name of the journal, give the publication date. All the things with the red star are mandatory to publish. Then the name of the author and their affiliation, so you need to choose that. And then you have a summary of the data. I put an embargo, so it won't be accessible before this date. And then you valid, and your document is online, or will be online, actually. So this is an example for R, but globally it works the same for everything in every repository. Then what about data? What to deposit? It's also the underlying data. It means you don't have to put all your data online, all the data produced during the project, but mainly the one that you will be using as underlying data for your publication. And the associated metadata. And you need to do it as soon as possible. If you want to provide other data produced, raw data, data that are not directly linked to a publication, you also need to associate metadata and specify when you will publish them in the DMP. So the principle of the EJD pilot is as open as possible, as close as necessary. So European Union is also willing to have patents and to have a great return on investment about the research she financed. So the idea is not to jeopardize patents or technology transfer by open access dissemination. You need to do it as openly as possible, but as close as necessary if you have other interests by doing so. Then, since January, European Union introduced a new way of seeing data management, and to help researchers to comply with those open data, with this open data pilot, they say that the data, the shared data, need to be fair. Fair means that they have to be findable, accessible, interoperable, and reusable. So very briefly, because it can be very long to explain with more details all that, but findable means that it should be persistent on the web, and not having an EWOR after 2 weeks of publication on the web. To do that, you need to have persistent identifier like DOI, ARCs handle that are usually provided by the repository where you are putting the data. This is the case for Xanadu. Then you need to have metadata and a good indexation to be sure that your data will be referenced by a research engine. To be accessible, so as accessible as possible, you need to have them localized somewhere on the web, put them into a repository on a website, but on a website that is well referenced again by a research engine. And you need to be sure that you have the right type of embargo, that your data are also anonymized if they need to be. So being accessible, meaning also taking all the precaution to make them accessible according to the law, author rights, and whatever needs to be respected. To be interoperable means that they need to be in open and free formats like XML, CSV, preferred text, RDF, DDI, whatever kind of data and metadata format that are freely used regarding the software that you are used at the beginning to create them. It also means that you need to put them into repositories that use standard protocol to exchange information, like the OAI PMH or other type of link data, for example. And then data needs to be reusable. It means that you need to have sufficient indexation tools, sorry I forgot the O, and metadata, and also need to have an open licensing. Licensing your publication is very, very important, because if you don't do so, you create ambiguous content on the web. If you don't have a license, how can someone know if they have the right to reuse it or not? So if you want to do open access, please don't forget to put the right type of license on it. So I will go pretty quickly on that because we don't have the time, but DOI is attributed by an agency, which is called the data site. And to have a DOI, you need to provide minimum information about the content, so name, creator, title, publisher, publishing year. And because most of the data sets and data today have a DOI, you can also find other data sets by using the data site's research engine. So you can browse by resource type, publishing year, and data center. So it can be useful if you as a researcher would like to reuse other data and not just as a publisher. To be accessible, so how do I choose the right type of repository? You can find disciplinary repository, which are better because the data sets will be described more precisely and in the same way. So for example, GenBank for genetics data sets, Simbad is for astronomy, Pangaea is for earth science, and Nakala is a repository for digital humanities, a French one. Then by financing institution, Horizon2020 provided Xanadu as a repository. Research organization repositories, AR for France, University of Lille, MiRoR for science, and SPEAR for sciences politique. Publisher repository also, PLOS1, or Nature have their own repository, or global multidisciplinary repository, usually born from individual initiatives, but the problem with those kind of repositories is that we don't know the business model behind. So it's almost like using Facebook. You don't exactly know what will be done with your data, and the policy can change anytime. So how to find a right type of repository? You can use the R03 data, which is a global repository for research data, a global tool for searching data repository. And again, you can grow them by the type of data, name of software, lots of information that you can use. To be interoperable, very important thing is that you have good quality metadata, as I told you, and open source tool. So there is, for example, a Wikipedia page where you can find the correspondence between closed formats and open formats. And metadata is globally what will make your data reusable, citable, archivable, upright, interoperable, and findable. So there is different kind of metadata. And what is a metadata? Metadata is, for example, if I take the example of a jam pot, the media will be the pot, the data will be the jam, and then the metadata will be all the information that explain you that this is a jam, that you have to edit before this date, extra. So metadata is what makes your data understandable and sustainable and whatever things is written there. To find the right type of metadata, you can use disciplinary linked metadata standard, and if you don't know if there is one for your discipline, then you can use the DCC search engine. For example, there is TF for climate and forecast for metadata in climatology. They use the EML standard in ecology, and Darwin Core in genetic, for example, or in whatever kind of research discipline that is linked to. Or you can also use the RDI Research Islands directory to see what kind of standard exists for your type of data. So you have the link there. You can give a look after this presentation. There is also the repository linked with the data. For example, if you put your data in Dataverse, which is the data repository of Harvard, you can choose one type of metadata standard which is according to your discipline. If you put it in Pangaea, they have implemented a metadata standard in the repository, so you don't have the choice, you need just to go through the different fields. Or in GenBanks, which is another type of repository, you have also a repository linked metadata standard. So this was an example. And to have reusable data, so this is what I told you before, you need to have the right licensing tool or to choose the right license. So for publication, you have the Creative Commons license. You can also use compatible license with the Creative Commons. For example, in France, the French government provided the licence ouverte, which is compatible with Creative Commons license. For database, you can't use any type of license. You need to use Open Database license, which is the ODBL license. This one is used for data and database, and for example for software and coding, the open license is the GNU license. So for each type of document, each type of material, you have a different kind of open access license. And if you use this kind of tool, I will maybe come back later about on UDAT, but UDAT provided a license selector tool where you can say, it's kind of a decision tree where you say what kind of data you have, what is the format, what you want to do with it, and then they propose you different type of license that you can choose. So if you don't know which one you should choose, you can log into UDAT and then use this tool to find the right one for your data. So now we have 15 minutes, so I will go into Xanadu and just show you what you can do and how you can comply. You will see it's very, very simple. So first, Xanadu is a catch-all repository that enable research scientists, EU project institution, not only EU project, but mainly it was created for EU project institution to share research in different formats. With quite simple metadata. It is not a discipline driven repository, so that the metadata will be linked to the type of data you will deposit, but even if it's a data set, you will have the same metadata, whether it's a data set in human science, in genetics, in astronomy, etc. So that's the only problem with Xanadu. It's not very precise, but it's convenient, and it will help you getting credited by making your research more accessible, and it will be integrated into the research output with OpenAir portal. OpenAir is, I will come back to that later also, it's a global portal that tries to reference every publication and every dataset, every project financed by the European Union. So to respect the requirements of the European Union, at the end of your project, your data, your article have to be referenced by OpenAir. And if you put your data and your article in Xanadu, you will automatically be referenced to OpenAir. Alright, so first to go to Xanadu, you need to log into Xanadu. So you just go on Google, you find the right page, and you will log in. So you can log in with your GitHub identifier if you have one. You can use your ORCID if you already created one. So ORCID is a unique researcher identifier that you can use to discriminate yourself from other people who could have the same name as you have, or to make your research more visible by being very easily linked to your name. So I will use my first, my own address for the example. Then, once I've been logging in, I can upload content. So, for example, I prepared some example about my vacation memories, which is absolutely not about research, but it was just as an example. So I can make a new upload, or I've saved a proposition that I have made. So I can drag and drop files there. So to choose files, I just have to click on this button. I'll choose the vacation picture, and they download it. So I can start the upload. I won't do that yet because it's not interesting for Xanadu, so I don't want to make a real deposit, but I show you it's very simple. You have the size, you have the file name, and you can do it with all kind of formats. Then you need to specify what type of data you've been uploading. Publication, a poster, presentation, dataset, image, video, whatever. So it's, in this precise example, it's images. And if I change the type of data, the metadata below will also change. So the basic information I will have there will be about the figure. Okay. So here I have my DOI. So I didn't have a DOI previous to my deposit into Xanadu. So whether your publisher have already give you a DOI for your article or your dataset because you publish them somewhere else and you already have a DOI and you can put your DOI here, or you don't have a DOI and Xanadu will provide one. As you can see, there is Xanadu there. So it's generated by the repository. And I can pre-reserve one if I don't want to do the deposit there. It was a saved proposition, so I pre-reserve my DOI even if it's not published yet. Then you have to precise the publication date, the title. I choose this one. The author, I'm the only one, but you can add as many authors as you like. And you need to provide a quick description of the data. So I'm happy to share with you my picture of the Curie National Park in Cappadocia. So I put some keywords. You can add additional notes, but it's not mandatory, it's optional. So you can see it's pretty quick and not very difficult. Then you need to find the right type of license and the access right. So is it open access? If yes, and I go through the process, then all my pictures will be available in 5 minutes on the internet. Or I can give an embargo date, 6 months, 12 months, not more, because you are you are under the H2020 requirements. You can be closed accessed. As I told you, managing data doesn't mean that you have to share everything, so you can also upload data and not sharing them, but at least guarantee kind of a more preservation process, better preservation process. Or it can be a restricted access during the project with only the partners, for example. So I will choose open access, and I will choose the right type of license. So Creative Commons have different way of protecting your data while sharing them. So you can ask at least to be credited for your work. So this is the CC BY with attribution. The share alike, it means that everyone that will use your data has to share the product that they will produce with your data in the same way you share them, so using the same license. With non-commercial, it means that everyone can use your data, but not in a commercial, with a commercial objective. Should be free services. That their non-derivatives means that you can use that, but you can't modify it, and you can combine different restrictions like non-commercial and no derivative. So I choose the more open one, the first one. What kind of community? For example, this one is not okay. Xanadu have different kinds of community they created. For example, they've created the European Commission Funded Research. I encourage you to choose this community because it will make your research more visible on open air. But you can create a community for your own project. You can create a community which is linked to a specific discipline, for example. So it's kind of collection that you choose to create to put your research, your project in. Well, okay, this is not very convenient. But it's not mandatory. There, very important, you need to put the name of your grant, the number of your grant. This is what will allow Xanadu to link the data and publication to the project. So I don't have your grant number, but you should add it to this place. And then there is other type of optional metadata or optional content that you can specify, and this is important. If you have put into Xanadu data sets and article and you want to link them together, because this data set is linked to this publication, this is where you need to put the information. So if I had an article related to my pictures, I should enter the DOI of the article and explain the links between them. Is part of this upload, as this upload as part, is cited, is supplemented by this upload, etc., to type the relationship between one content and one other. And then, when you're done, so you can put some more subjects, you can specify if it's a TEDx, what is the university awarding, if it's a conference, what was the conference title, etc., etc. So there is a lot of information. You can spend a lot of time, or as you can see, very few time doing that regarding the type of information you are providing and regarding how well you want to make your data and your article visible and well referenced. It's almost the same for publication. If I choose a publication, I will have publication date, title, author, description, keyword. Metadata is almost the same for every kind of publication. And then you can publish it, which I will not do because it's not a real research project, or save it to publish it later, which I've done. And then, once you've been doing that, this is for data sharing, but you also have to preserve it. So as a free solution also provided by the European Union, you can also create an account into UDAT. So UDAT is a project, it's a European initiative which was financed by the previous research plan of the European Community, and it has different different services. Not all services are today usable, but you can at least use B2 Access. We can be a storage solution during the project as B2 Drop. There is also B2 Share. We can be a concurrent solution as Xanadu, where you can put your data, and this is into B2 Share that you can find the licensing tool, for example. So it's free. Even if you don't want to use it as a sharing solution, you can at least use other services provided by B2 Share. And everyone is waiting for B2 Safe to be operational, because B2 Safe can be a convenient solution for long-term preservation. But by putting your data into B2 Share, it will be easier to have them into B2 Safe after all. And then to conclude, after you put your data into Xanadu, because you will have information give information in the metadata about your grant agreement, the name of your project, and the call, your publication, will be linked here to the project MiRoR, which is already referenced into OpenAIRE. So if you search into OpenAIRE, you can find MiRoR. You have those information, the partner organization, more detailed information about the project. And as you can see, there is, for now, no publication, no research data linked to the project. But as long as you will, and when you will be putting your data into Xanadu and make them available on the web, your publication and your research data will be linked to this page and be visible on OpenAIRE. So this is what will guarantee you to meet the requirements of the European Union regarding H2020 projects.